Hello YouTube, this is UMOS03. So now we're on to lesson 30 in the Python curriculum. And in the previous lesson, we had just skimmed the surface of decorators. So in this entire lesson, we're going to talk about decorating functions. But it's important to remind ourselves of the theory of functions. But before we do that, I just wanted to share one more detail about the string formatting. It's something that we've talked about before, but this is code that we're going to talk about later on in the lesson. But essentially, remember that you can go ahead and there's different ways to do these things, right? So you can go ahead and say something like, what if you had said something like print of, and then you can go ahead and say something like X and Y, okay, dot format of, you could say something like Y equals Lincoln and X equals Abraham. Okay, so you just have to we have to remind ourselves that using the format function by default allows us to just reference the index positions of the arguments into the format function in the order that we want to use them, not sue them, within our string, okay? But we can also choose to have named arguments, okay? And then in PyCharm, in the particular integrated development environment, you can see that these are showing up in red, okay? And we're also getting a Python enhancement proposal. It's telling us that it doesn't like that we have so many spaces here, but hopefully you get the idea of what's going on here. So if we just tighten that up, hopefully it'll stop yelling at us. Maybe we had too much blank space up there. Okay, so this is another way to do it. It just basically means you can call these arguments whatever you want. So you could have said potato here, and then it would just go ahead and say potato, right? And then that's totally equivalent, right? And then this is equivalent to just if you said 0 and 1, right? And then you could have done the same thing, dot format of, and then you can just go ahead and feed these things in, right? So X here was going to be the first argument. So you do Abraham and then Lincoln. So hopefully that makes sense to you, okay? And then we said that this is all equivalent to if you just say F, and then you could do, and then you would maybe if you had variables already defined, okay? So you would just basically have to say, W1 equals Abraham and W2 equals Lincoln, right? And then you could just go ahead and say print of F, and then you could say W1 in curly braces, W2 in curly braces. So those just give you different methods for formatting strings, and hopefully those kinds of things are clear to you. Our understanding of functions, we know that functions can accept multiple inputs, only one or none at all. We know that functions can return something, print and not return something, or print and return something. A variable can be assigned to the output of some other function and then works the same way. That was called function reference variables. And we had some function that was called like referral, right? And it was set equal to another function which was called another example. Okay, so whatever another example returns for two inputs, referral of those two inputs would return the same thing that another example would have. A lambda function is a one-line way to declare the contents of a function. It's very easy to say f of x is 3x. You can do that literally with one line. Map of f iterable, map of function iterable is a generator that yields the outputs of f of x for all x in the iterable. A function, remember that's a generator. You don't say print map of f iterable. You say for w in map of f iterable. A function can be passed into another function and as an input and then called on one of the other inputs, right? Remember we said something like composite function, right? And then you can pass in an f and then an x, and then in the composite function you could just say print f of x. Okay, so hopefully that makes sense to you. That was in the nested function. So that was in lesson 14 if you're still unclear on that. Doc strings are specific comments that specify parameters and then either any values that are returned or yielded. Input types to a function must be sensitive to what the function does to those inputs. We talked about that. Generators are a special type of function, and tuple of x is a function that accepts a generator x and returns a tuple containing each element in x. So we already, and list of x is similar, okay? Inner functions, we already said you can have functions inside of other functions. We saw examples. So this one's pretty clear. I think we already saw basically that if F1 calls F2 and F3, and F2 and F3 are defined within F1, then if we call F1, it'll run F2 and F3. And so that's why on the console, you go ahead and scroll down, you see sup and not much. We talked about that in the previous video. And then we saw this other example. This one is a little bit trickier. So this one accepts an input, right? And then it's going to end up calling that input applied to F5, but we're just going to add 2 to it. And so 12 over 10, we said that that was 1, right? So it prints 52 and then 1. So hopefully that makes sense to you. And then we did the math on this problem. So this one's a little bit trickier, but this is another example. You have 3 inner functions here. Some of them accept inputs, others of them don't, but they all end up referencing information that was made available to F7. Okay, so you can say define F8, return X, as long as X is defined somewhere within this function. Okay, so in general, that's a more general point that we probably could have brought up earlier. Okay, but if you had said elephant equals 2, and then you define a function, and you say return elephant, well, that function has the class variables, the Python file variables available to it. And we're going to talk more about that kind of accessibility and privacy features pretty soon when we move into object-oriented programming in about 2 or 3 more lessons. So anyway, what we're going to do is we're going to talk about decorators. So remember, we said decorators are functions that can enhance a main function f. And a decorating function accepts the f as input and returns an enhanced version of it. Within the decorator, there's also an inner function, which is we call it a wrapping function, okay? And it doesn't accept any inputs, although it can call f because f was passed into D, the decorator, and the wrapper function is defined in terms of the decorator. We just talked about an example of that, right? X is available to F8, even though X is not technically an input of F8, okay? And the same thing's gonna happen with decorator. So we could scroll down to the example here. This print favorite function, we talked about it earlier. Go ahead and ignore this kind of ugly yellowish green color. We're going to talk about that. But this would be print favorite. Okay, so then we're just going to print pizza. But then what this line 222 does is when we call the decorateMe, we're saying, Python, I want you to decorate this function. Okay, and you can call the decorator with anything you want. You could have called it hot dog. Okay, and then you would call at hot dog. But what it does is it basically is going to reformulate or enhance this function in such a way that its original implementation is just going to fit right here on line 217. And then as a result of decorating it, you return what the wrap function gives. So what does the wrap function give? Well, it prints a string. Let's decorate with something before for each decoration. And then the result of f, whatever f was when it was passed into the decorator. And then let's decorate with something after for each iteration. And so that's essentially the decorator. So I'm trying to go back and forth between showing you the example and explaining the concepts, but it's kind of hard to do one without the other. So the inner function W wraps f by printing something before the call to f and or afterwards, okay? And then to apply a decoration D to a function f, you need to add at D. So the at symbol and then D on the top of the definition of f. And then in a minute, we'll talk about another way to do it, okay? So what we're gonna do is I wanna show this to you. And actually it already printed on the console so that, we can go ahead and run the code again, but it already printed on the console. So remember we had the result is -6, that was from the previous example, but then we scroll down and we can go ahead and look at what happens, right? So then we go ahead and see, let's see what happened here. So then what happens is we call print favorite, okay? So we're basically called line 230. And if you keep scrolling down, it's all doc strings, it's all comments. So the last thing that got printed, last thing that was executed was line 230. It says print favorite. Okay, well, print favorite, it doesn't just print pizza. Okay, the print favorite function has been decorated, it's been enhanced. So now we basically say, take this implementation of print favorite and put it into the decorateMe function as an input. Okay, so now this is the simple implementation of f. But now f actually runs the decorateMe function with f itself inputted into it. So that's essentially what we have going on here. And then if you ran it twice, then you would see it printed twice. So now if you go ahead and run it, you get 2 wraps. Okay, so let's decorate with something before for each decoration, and then you go ahead and see the pizza there because that's the function that was getting decorated. What if you had said something else? What if you had said like print least favorite and then you had said tomato here, right? And then you can decorate any function you want. So now you can go ahead and say print least favorite, right? And then you can go ahead and run it. And then, you could just say tomato, right? And then you could have different ones, right? You could have multiple functions that are decorated. So now you can scroll down. I suppose we didn't really need to delete the original one, right? So now both of these functions are decorated, and now both of them have this decoration applied. They've had enhanced, they have functions, they have additional functionality that's being returned, that's being printed. And you have to be careful about the data types here. So if you're trying to replicate this on your own, Decorators, I would say, are one of the trickiest concepts in Python. This is one of the hardest things we're going to talk about because the syntax is kind of tricky and conceptually it's a little bit strange and bizarre with what's going on here, but hopefully this makes sense to you. And so it decorates those two functions. So hopefully that makes sense to you. What we can also do above on line 227, we see that at decorateMe means that print favorite is re-enhanced to decorateMe's implementation of print favorite. That's what's going on here. So now when we call print favorite, we will really just be calling decorateMe with print favorite as an input. And that's the concept of a decorator. Okay, so we're going back and forth here. The theory, it enhances the main function f, it accepts it as input and returns an enhanced version. It has an inner function or wrapping function, which we can call w, okay? W doesn't accept any inputs, but it basically uses f. And then the other thing that w does is it might print something before or after f, right? Before and after f usually, you know, that's what it says here. Just enhancing it, coloring it, decorating it a little bit, you know, giving it stars or something, right? And then to apply a decoration d to a function f, either add d on top of, add at d on top of the decoration f, on top of the definition of f, or write f equals d of f after f was initially defined, and then you can call f. So let me show you what I mean by that. What we're going to do is we're going to remove the decorator, so we're going to undecorate both of these methods. But then we can go ahead and run these functions. So I'm going to bring those back. But with them instead, these undecorated methods, what we're going to do is we're going to say print favorite equals decorateMe of print favorite. Okay, so this would be equivalent to writing decorateMe on top of the print favorite header, on top, like right on 225 there essentially. Okay, so hopefully that makes sense to you. Okay, so this would be equivalent. So now let's go ahead and see what would happen if we run print favorite, and indeed the function is going to be enhanced. It's going to be decorated and you get the exact same thing. What happens if you have two decorations? So what happens if you say print favorite? Now what if you go ahead and say that again? So now what we're going to say, we're going to decorate it again. So now we're going to say print favorite. Now let's go ahead and run it, and hopefully you can form your own prediction about what's going to happen. So this is a decoration of a decoration. Okay, so basically what happens is, by the time, you know, you start with the original print favorite, and this would just be printing pizza. Okay, and then as a result, once you apply decorateMe, then with this print favorite, if you call it after line 230, then it would say, let's decorate with something before for each decoration. Pizza, let's decorate with something after for each iteration. But then all that mess, you're going to plug it back in, and you're going to decorate all that mess. So it's going to decorate the decorator. Okay, so that's why you have basically this stacked decoration, is you're decorating the version of the decoration. Okay, so that's why you have that here. So basically, I think I had a line, if you have multiple decorations on a function f, the decorations decorate each other. So you have to, so you have stacked initial decorations on top, then the function call, and then stacked closing decorations below in opposite order. So what I mean by that is that this line right here corresponds to the inner decoration, right? That corresponds to like the first decoration. And then this is like the second decoration that we had, okay? But then on the top, it would be the opposite, right? This would be like the most recent, the second decoration. And then in this one, what you see below that is actually the initial. That was the original decoration that in turn ended up getting decorated, okay? And you can mix and match the formulations of that. So we said if you want to decorate something, you either say main function equals decorator of that function, right? F equals D of F, or you just say at D on top of the definition of F. So now you have a triple decoration. So now you can go ahead and run it. Let's see, no, not D, right? decorateMe, right? So now you can go ahead and run it here. Okay, so now you have a triple stacked decoration. So hopefully that makes sense to you. That's the concept of a decorator, okay? It's kind of tricky, but hopefully what you have an understanding of what the wrapping function is doing, and then you just return wrap, and that's the effect that calling decorateMe has on a particular function. But in general, you know, these are tricky, and they don't seem to work well with other inputs, okay? So use this specific notation and just proceed cautiously, because this kind of procedure does give its way to errors sometimes, okay? We'll talk about one more function. We're going to talk about the division function. Okay, so division of a and b. We're going to think about another simple function. So this is an example of a function where you can bring in inputs. So how does div of a and b work? Well, it returns a over b. That's pretty intuitive, right? But what we're going to do is we're going to apply the better div decoration to it. So basically this is equivalent to div equals better div of div after div was defined. So writing that after like 37. Okay, so hopefully that makes sense to you. But what does better div do? So basically we have a Python enhancement proposal suggestion. It says you have too many blank lines. And like I've said before, you can choose whether or not you're going to let that bother you. If you don't want to let it bother you, you just say ignore errors like this. Okay, it accepts a div. It accepts a div. What is div? Well, according to these parentheses here, it has to be some kind of function. What kind of a function? It has to be a function that accepts two inputs. So for example, div of AB seems like it's a function that could be accepted into better div as an input. And then we have a wrapper function. So this wrapper function, this inner function, I literally decided to call it inner, accepts two inputs. If the first input is less than the second one, it's going to flip them. So remember, we said a few videos ago, we said that this has the effect of swapping the values of x and y. Okay, so that would say, but if x is less than y, then I want you to make x be y and y be x. So x, at the end of this, it's going to return div of x, y, but it's going to do it with x being the larger of the two numbers. Okay, so why would we want to go ahead and write something like that? Because if someone tries to say, give me the division of 5 and 25, like how many times does 5 go into 25 basically? Well, if you did that mathematically, if you did that on your calculator, you would get 0.2. And they would say, well, it seems like there's more than 0.2 groups of 5 in the number 25. And you would say, well, you did the reverse operation. So as a result of decorating this function, what we're able to do is we're able to check to make sure that when the person called div, they enter the inputs in the right order. So what this does is it says div, don't use this original naked simple implementation of div, use the enhanced version. So what's the enhanced version? Well, basically it uses the simple version right here, but we can't use the simple version until we check to see if the first number is less than the second number. And if it is, we swap them. That's the effect of the inner function, okay? And this is how you pass values in, okay? So if your main function has inputs into it, then those would be inputs to the wrapping function, okay? But your main function is an input to the decorator, okay? So now if you go ahead and try to run this, I don't know, we should already be printing this on the console somewhere, but that's probably the 5.0 there, right? Because we were talking about the Abraham Lincoln and the three different ways of doing the same thing, right? And you'd have to remember a space. So you could go ahead and put a space there, and a space there, and a space there, and there would be no problem whatsoever. So now, oh, press the wrong thing, but you can go ahead and run main.py. That's a little bit cleaner. But what we were talking about is down here. So now it says div of 525. Well, let's go ahead and think about that. So ordinarily, if you had not called div equals better div of div, or if you hadn't assigned the at better div on top of the definition of div, then it would just have given you 5 over 25, which is 0.2. But as a result of applying this enhancement, it's going to stick the div as an input into better div, okay? And then it's going to basically allow x and y as inputs, okay? And it's just going to check to see if a is less than b. If it is, we're going to flip them. So is 5 less than 25? Yes. So instead, I want you to run div, but I want you to run it with 25 as the first input and 5 as the second input. And then it runs the simple implementation, but basically, the inputs have been swapped swapped versus how they were received. So hopefully that makes sense to you. And this works for other inputs. So what if you had passed it incorrectly? What if you said div of 8.1? Would this return 8? Or would it return 0.125? So let's see if it got it right. Gave us 8.0. Why does it not give us 8? Because we said that a number divided by a number in Python is always a float, even if it would be perfect integer division. Okay? And then obviously if you change the definition here, so if you say A over B, okay, it can still decorate it, can still do basically what it's supposed to do as far as swapping the values goes, but now you get integers, okay? So hopefully that makes sense to you, and that's basically the essence of decorators. And so you should basically focus your attention not so much on the division example, but at least be familiar with the printing pizza example that we saw here and understand what a wrapping function does and why we need it. So that's enough for now from UMilso3. Thanks for watching, and please subscribe.